Okay, so now you know why you should be using a local test or sandbox environment. So what does this environment look like? First, it consists of virtualization software that will allow you to run Linux inside a virtual machine on your local desktop or laptop. My favorite virtualization software for this purpose is VirtualBox, available for download at virtualbox.org. First off, it's free to download and easy to install. Secondly, it runs on Windows, Mac, and even Linux. This is a big plus for a course like this, as you're going to have the same experience if you're working on a Windows system or even a Mac. If you're looking for a virtualization solution for running virtual machines in production, I'd be looking at something like VMware, KVM, or Overt. But for our purposes of creating test systems on our local machine, VirtualBox is the way to go. Let's get clear on what VirtualBox does and what virtual machines are. VirtualBox is a full virtualization product, meaning that it allows you to run an unmodified operating system with all of its installed software in a special environment on top of your existing operating system. This special environment, called a virtual machine, is created by the virtualization software by intercepting access to certain hardware components and certain features. The physical computer is called the host, while the virtual machine is called a guest. Most of the guest code runs unmodified directly on the host computer, and the guest operating system thinks it's running on a real machine. This last point is important. The guest operating system thinks it's running on real hardware and really doesn't know that it's inside a virtual machine. If you're doing something inside a virtual machine and the operating system of that virtual machine says something like, "Performing this action will erase all the data on your disks," it's really only referring to the virtual disk it has access to, not your physical disk on your real physical host computer. You can perform destructive actions inside the virtual machine, and those actions are contained inside of that virtual machine and won't interfere with your actual physical computer. VirtualBox provides software that can be installed on the guest operating system. This software is called VirtualBox Guest Editions. This software allows the guest operating system to access shared folders on the host system, share the clipboard, and other similar actions. This is not required, but it can be useful. The virtual machines you'll be deploying in this course will already have the guest edition software installed in them. I just want to mention the guest editions so you're aware of them and what they do. Manually creating virtual machines with VirtualBox is fairly easy and straightforward. First, you start VirtualBox. Next, you click on New to create a new virtual machine. From there, you give it a name, tell VirtualBox a bit about the operating system that you'll be installing inside of the virtual machine, and allocate some resources such as memory and disk space to the virtual machine. When you create a virtual disk for the virtual machine, you can make it dynamically allocated. A virtual disk is simply a file on the host system. When you choose to dynamically allocate that disk, it will only use space on your physical disk as that space is used inside the virtual machine guest. This means that the disk file will grow as needed. The upside is that the virtual machine thinks it's getting a large disk, such as 100 gigabyte, for example. But if it only uses 1 gigabyte, then only 1 gigabyte of space is used on your physical hard drive. The price you pay for dynamic allocation is performance inside the virtual machine, but for our purposes, this is totally acceptable. Once you've allocated resources to the virtual machine, it's ready to be used. The first time you start it up, it will ask you to attach a disk to boot it from. Typically, what you'll do is download a Linux ISO from your favorite distribution's website, and then tell VirtualBox to use that ISO to boot the system with. Alternatively, you can actually put a physical CD or DVD in your computer and tell VirtualBox to use that physical drive for the install. Now you install the OS in the virtual machine just like you would if it was on physical hardware. This process is all well and good, but as you can probably guess, it can be a bit time-consuming going through the virtual machine creation process and manually performing the operation installation each time you want to create a new virtual machine. We're looking to automate this process and save us the time of doing this work. To do that, we'll use a command line tool called Vagrant, which is available to download for free from vagrantup.com. This command line tool works on Windows, Mac, and Linux, so no matter what OS you're using to take this course, you'll be covered. Vagrant provides easy to configure, reproducible, and portable work environments. By default, Vagrant provisions virtual machines using VirtualBox. It can be configured to deploy virtual machines to VMware, AWS, which is Amazon Web Services, Rackspace, and other providers, but for this course, we're going to stick to creating virtual machines inside of VirtualBox running on our local system. You're going to use Vagrant to quickly and easily spin up virtual machines running Linux. In the first project, you're going to get a lot of practice using Vagrant. For now, let's just talk about what you should know and understand about Vagrant before you start using it. A box in Vagrant speak is an operating system image. The Vagrant box add command will download and store that box on your local system. You only need to download a box once, as this image will be cloned when you create a new virtual machine with Vagrant using the box's name. The typical format of this command is vagrant box add user/box. I have a user account on Vagrant's public box catalog system. My username is JasonC. I created a box specifically for this course named CentOS 7. It's really just a minimal CentOS install. So to download that box, you would run vagrant box add JasonC/CentOS 7. There are several boxes that are publicly available on Vagrant's public box catalog system. I'll have a link in the project instructions where you can download other boxes if you'd like to experiment with them. In addition to boxes, Vagrant uses the concept of projects. A Vagrant project must consist of a folder and a Vagrant configuration file called a Vagrant file. So to create a new Vagrant project, first create a folder. For example, I would open up a command prompt on Windows or a terminal on Mac and type mkdir VM1. From there, you just change into that directory, for example, cd VM1. Now you need to initialize your Vagrant project, which means creating a Vagrant configuration file. This configuration file is named Vagrant file, and it contains the box name to use for the project and any other configuration options for the virtual machine to create. To create the Vagrant file, run the vagrant init user/box command. So continuing with our example, you would run vagrant init JasonC/CentOS 7. Now you can bring up an instance of that box by running vagrant up. The first time you run the vagrant up command, Vagrant will import or clone the Vagrant box into VirtualBox and start it. If Vagrant detects that the virtual machine already exists in VirtualBox, it will just simply start it. By default, when the virtual machine is started, it's started in headless mode, meaning that there's no UI for the machine visible on your local host machine. Since this class is focused on server systems, we'll be working at the command line, so we really don't care about looking at the Linux desktop anyway. Now, if you look at the VirtualBox application, you'll see that you have a virtual machine that is running. Its name starts with the name of the Vagrant project, which is the directory name. SSH, or Secure Shell, is the network protocol used to connect to Linux systems. Vagrant provides a really nice shortcut to SSH into the virtual machine. Simply run vagrant SSH and you'll be automatically logged into the Linux system. To log out of the Linux system, type exit and hit enter. A quick note for you Windows users, Windows doesn't currently ship with an SSH client, so you'll need to install one. I recommend installing Git from git-scm.com, which includes an SSH client. When you work on the project, I'll give you specific instructions on how to get this configured. For you Mac users, you'll skip this step as you already have an SSH client installed by default. Okay, back to Vagrant. Vagrant can be used to control the virtual machines it creates. For example, the vagrant halt command shuts down the virtual machine. When you run this command, you won't lose any work you performed on the virtual machine. The virtual machine will still exist in VirtualBox, but it will just simply be stopped. To restart it, run vagrant up. Since the virtual machine already exists, vagrant up will simply start it and will skip the import process because it's not needed. If you want to suspend the virtual machine, run vagrant suspend, and to resume it, run vagrant resume. Doing this saves you the time it takes to reboot the operating system, and then you can save exactly where you're at if you want to. If you're done with the virtual machine or you want to start over with a fresh copy of the virtual machine, run vagrant destroy. This will terminate and remove the virtual machine from VirtualBox. If you run this command, then any work inside of that virtual machine will be lost. If you need help, run the vagrant command without any options. Also know that the vagrant command will act on the virtual machine associated with the vagrant project directory that you're in. During this course, you'll create multiple vagrant projects, so be sure you're in the desired vagrant project directory before running any vagrant commands. Before we wrap up talking about Vagrant, let's take a quick look at a Vagrant file. All the Vagrant configuration occurs after the vagrant.configure line and before the end keyword. The 2 in parentheses is the configuration version. Older style configurations are supported, but we'll be using version 2, so this is what you'll see in the Vagrant files you'll be working with. The simplest Vagrant file just specifies the name of the box you'll be using for the VM. If you want Vagrant to set the hostname inside of the virtual machine, you can use config.vm.hostname. To assign a static IP address to the VM, use config.vm.network. The example on your screen will assign the 10.2.3.4 IP address to the virtual machine on a private network that can only be accessed from the host machine or other Vagrant VMs on that same network. You'll be using this Vagrant feature to create an entire private network of Linux systems that can communicate with each other. Each box ships with a set of defaults like whether or not to start in headless mode and how much memory to allocate to the virtual machine. You can override these settings by using a config.vm.provider block. The example on your screen will force the virtual machine to start with a GUI and use 1024 megabyte, which is a gig, of memory. Vagrant has a provisioning system built into it. Provisioners in Vagrant allow you to automatically install software, alter configurations, and more on the machine as part of the Vagrant Up process. During much of this course, you're going to run Vagrant Up to quickly create a VM running Linux and then go about manually installing software and performing various configurations. However, if you want to automate this entire process, you can create a shell script and have Vagrant execute that shell script the first time Vagrant Up is executed. The example on your screen will upload the setup.sh shell script to the virtual machine and execute it. This way you can automate and reproduce environments quickly. If you want to make sure someone else, like a developer, is working with the same configuration as you, give them the Vagrant file and the setup.sh script and they're set. We've talked about many of the awesome things Vagrant can do and many of the Vagrant features you'll be using most often. However, there's more. The vagrant init command creates a default Vagrant file which contains several comments. You can read through those comments to get some ideas of what else is possible to do with Vagrant.